good morning and good afternoon, everyone. And welcome to this tech talk where we will focus on what we call BOM validation. Now, to explain what this concept is all about, I'd like to first start with the subtitle here on delivering on the configuration promise. So for now, imagine we all work for a company that sells bikes, highly customizable and configurable bikes. And the way we communicate with our customers is by using a configurator. So we have this happy customer. He goes to our configurator online and he starts configuring a bike. So this customer, he might want a city bike. He tells us that he's a casual user. Maybe he just uses it for commuting to work. He liked the color blue, and he might want to have this fancy feature of having a belt drive on this bike. So by the time that this customer of ours, he's done configuring and he clicks the order button, we actually make a promise to him. We make a configuration promise to this customer. Now, at the time where this order is about to be manufactured, we create a unit BOM, and this unit BOM is specific to this user's configuration. Now, unfortunately, sometimes this bike, when it's manufactured, ends up looking, something like this. That's called a misbuild, and it happens when the created unit BOM is invalid. Now, at this point in time, we might have to call the customer and inform him that we couldn't keep the configuration promise. Maybe we have to change the configuration a little bit. Maybe the price has changed. Maybe the delivered date is changed. But at the end of the day, if we cannot keep this configuration promise, you can see, he's no longer any happy customer. So today's tech talk, I will look at three things. I will look at the data behind this scenario. I would look at what went wrong, and then we're going to talk about how can we actually avoid it. So this is about BOM validation. So first, let's take a look at the data behind this scenario. So this talk today will not focus on where we maintain data. I did a tech talk previously. You can find it on Configit's homepage, which talks more in detail about the data behind this scenario and where data is maintained. But today I'll go fairly quickly through the data definitions, and that we should have enough foundation to get moving to BOM validation. So the picture I'm building will have, I will use three colors here. I will use the color blue to show data which has a marketing or sales intent. I will use the color yellow to show data that has an engineering intent. And I will use the color red here to show something that is of manufacturing intent. So the example we started off with showed a sales configurator, and this is kind of where the story starts. So when we communicate with our customers, we use what we call sales features. So a sales feature is it's an abstraction describing customer requirements. So for instance, if we're selling bikes, as we are in our imaginary company, the requirements that we allow a customer to choose from could, for instance, be what type of bike do you want? Is it a normal bike? Is it a mountain bike, a road bike? How tall are you? What color do you want it in? Maybe something about which market to use this bike in. The build, is it a normal build, lightweight or ultra lightweight, etc. These are all abstractions. They're not parts, they're abstractions. And those are the ones that the customer would choose. These features here, each of these choices, they're organized into what we call feature families. You might also have heard the term variables or characteristics. It depends a little bit about what language you speak. Anyways, I've colored them blue because they're sales and marketing intent, and I'll put them up here in the blue box here where we build up our marketing data. Now, a configurator is driven by what we call a product model. I'll use the word product model and the word configurable module a little bit interchangeably in this talk. In our example here, our customer was configuring what we call the Bike 2000. That's a product. And the first step he was doing, it was interacting with all of that. So in order to interact with a product model, we have to define what features are in that product model. So building up a configurable module, we assign some features to it. And these features, they describe the variance of the module or the variance of the product. Once we have that, we need to add some rules to our configurable module. And the rules here, they define the valid feature combinations or the valid configurations. So they actually define what is it that we offer to the customer. Okay, so the sales model, of course, belongs to the sales and the marketing intent. And once we have a sales model, we can start to drive a configurator, just like we saw in our example. So the user would use this configurator to interact and choose a number of sales features, and thereby building up a configuration. So this configuration would contain the sales features chosen by the customer, as we just saw in our example. Now, the complexity of a product is not just captured using sales features. Usually we would have a lot of technical features that are used to express the technical variants of our product. Now, a bike is fairly simple, but if you look at how a bike is engineered, you'll probably find there's a lot of technical features associated to it. So for instance, I just made something up here, but if you look at a bike, you will find out that on a bike, there will be a front and a rear derailleur. Those are the ones that move the chain when you change gear. And for instance, the front rear derailleur might have multiple ways of being fitted to the frame. So when you engineer this bike, you would have to figure out how can I fit the rear derailleur to the frame. That will be something about the number of cogs on the cassette. That's the number of gears that the chain runs on. That will be something about the cog pitch, the distance between the cogs in there, how much cable we pull each time we change gear, etc. All of that are technical features. And we'll put them here in the yellow box, which is our engineering intent. Just like we could define configurable modules for sale, we might also define technical configuration modules. And these technical configuration modules, what they do is that they tie the sales features and the technical features together. So the technical configuration module, they might actually be strongly connected to the structure of the product. So for instance, for a bike, we might expect that the bike has a gear system, handlebar, frame, etc. So we might actually have a technical product model or technical configuration module for each of those parts. What we do is that we combine the sales and the engineering knowledge by including these technical modules into the sales model. And that way we get a combined model which represents both sales and technical rules. So with this combined model, we can actually use the rules in the technical modules to expand the configuration such that the technical features also becomes part of the end configuration. And this gives us a complete configuration we can use once we get to bill of materials. Now, finally, in this data picture, we have the BOM. So a BOM is defined as a hierarchical structure with parts and assemblies. And the BOM, of course, is part of the BOM system. In this picture, I will put parts and assemblies in the red box here because I think of the end result as being a unit M-BOM. It's a BOM for manufacturing. I know usually you would think about E-BOMs, and E-BOMs would drive the definition of the M-BOM. When we validate a BOM, we would usually validate an E-BOM, but in general, don't hang yourself up too much about what's E-BOM, what's M-BOM, just think BOM in this example. Now, just to look at this BOM for a minute to decipher it, what's actually in this BOM. We have a Bike 2000 product, and that Bike 2000 has a Bike 2000 bill of material. So this bill of material is composed of a gear system. It has a handlebar, a logo sticker, etc. And the gear system here has a rear derailleur, a cassette, etc. Now you'll notice that in my bill of material here, I have some of my assemblies which has a little dash and some which has a little star here. The ones with a little star here is what I call BOM variants. It has a lot of other names in different systems, variability items or BOM classes. But what they are is they are groups of parts with individual functionality. So for instance, this rear derailleur here with a little star on it is a BOM variant that encapsulates a number of actual, this rear derailleur here is a BOM variant that captures a group of actual rear derailleurs. So each of these parts is a rear derailleur. And this is just a collection of them, a variant that represents some rear derailleur. We make the BOM configurable by adding what we call selection rules. They are also known as usage statements or selection conditions. Basically, they're just Boolean expressions that define when to include parts in the final bill of material. So for instance, I could say for the rear derailleur, this specific rear derailleur should be used if we have 11 cogs, and this is the cockpit I choose. These selection rules, they may refer to both technical and to marketing features. So I can have another rear derailleur here that is included if I have in this case, I guess it's 11 cogs and specific market, and then it goes with a combination of different cog pitches. So if I add selection rules to my BOM, we now have what we call a configurable BOM. It's also known as a super BOM or as a 150% BOM. It has a few names. And when I refer to BOM validation going forward, what I'm referring to is I'm referring to the validation of the configurable BOM, the one here to the left, against all the rules and features I have in my configuration system. Okay, so selection rules, which makes the BOM configurable, they're considered part of the BOM information. And this concludes the data setup I have. So at this point in time, we assume that we have features, we have rules and configurable modules, and those together drive the configuration. We have parts and assemblies, and we have selection rules, and that together defines our configurable bill of material. So in the example we had, the user created a configuration up here using the configurator, and this configuration was then married with the configurable BOM over here. So let's take a look at how that was done. So the configurable bill of material is actually filtered using the configuration we have here. And the way it works is that parts without a selection rule, they are always included in the resulting unit BOM. And parts where the selection rule or where the configuration satisfy the selection rules, they're also included in the result. And parts where the configuration does not satisfy the selection rules are left out. At this point, what we've done is we've taken our configuration and we created a unit BOM which fits specifically to this configuration. Now that brings us to a very big question, and that is this unit BOM valid? So looking at the data we have, we really have nothing to support us in answering that question. All the features, the rules, the BOM down here, nothing really tells us whether this unit BOM is valid or not. So we have to come up with some criteria that tells us when this is valid. Luckily, looking at the bill of material, there's a few things that stands out. So let's try to look at an example. How would we validate a BOM variant? This variant could, for instance, be the rear derailleur we talked about before. Well, the first thing we have to do when we validate a BOM or a BOM variant here is to choose the context that we validated in. And the context here is a configurable module. It could be a technical module. So if, for instance, if I'm validating my rear derailleur variant, it could be that I had a technical module for rear derailleur with rules about rear derailleur. But it could also be that I'm validating it against the sales model that includes my technical modules. So the first thing we do is we've chosen a module that we validate against, and this module has several features associated with it. The first check we need to do is to make what we call a structural check. And here, what we do is we compare the features in the configurable module with the features that is used in the selection rules of the bill of material. And it is so that if all the features in the selection rules are included in the configuration or in the configurable module here, that means we can use this configurable modules to filter the BOM. Now it's actually okay, and it's expected sometimes that we have more features in the configurable module than we have in the selection rules. So for instance, again, if I'm validating my rear derailleur BOM variant, and I'm validating against my Bike 2000 model, then I would expect to have a lot more of my features in my Bike 2000 model than what I am using in my selection rules of my rear derailleur. So in this case, we're validating a variant. So let's get back to these criteria of when my BOMs are valid. If I'm validating a variant, I would expect that any configuration would yield exactly one part chosen for this variant, because it doesn't make sense to create a bike without a rear derailleur. It doesn't make sense to create a bike with 5 rear derailleurs. There has to be exactly one rear derailleur. So BOM variants, they lend themselves to natural criteria. Make sure that every configuration gives us exactly one part. So how do we validate that? Well, we look at the available configurations of the configuration module. So in this picture, each row up here represents a valid configuration over the features in the configurable module. To be able to validate the configurations we have here on screen with the configuration module and validate against that BOM variant that we're looking at, we need to simplify things a little bit. So the first thing we need to do is we need to make sure that we remove the features which are not used in the selection rules of the BOM variant that we are validating. This operation here is called projection. So let's remove the features that are not used by this BOM variant. Once we do that, we will see that we have some redundant configurations back in the result here. I've tried to highlight that in using green boxes here. And if you look at each green box, what you will see is that all the configurations in each green box are identical. So the next step in this projection operation is to collapse these redundant solutions. Here we go. So we now have the configurations which are relevant for the BOM variant that we are validating. And just as a side note, if you're a database administrator or a database person, this operation is simply identical to what you would do if you say select the features I'm interested in and then distinct the results that comes out. For each configuration we have now, what we do is we evaluate which part we want to use for the BOM variant. So each row in the picture we have here depicts a valid configuration and the part that it maps to. So this configuration up here, for instance, this cable length, this byte type, and this, I think it was a mounting type, would yield this variant, this part in the variant D. Now, if we inspect what we have on screen now, we can see we actually have a few issues that we need to fix. So let's take some examples. This configuration I'm highlighting right here, it does not include a part for the BOM variant. And that means that this configuration would lead to a misbuild. So for instance, if again, this was a reader failure, I would know that if my user chose this configuration, the resulting unit BOM would not have a reader failure on it. This scenario is called under engineering. We call it that because we haven't engineered a solution for this configuration. There's another example up here where this configuration includes two parts for the BOM variant. And that means the configuration would also lead to a misbuild. So if I choose this configuration, I might get two rear derailleurs on my bike, and we can't fit two rear derailleurs. So that would be a misbuild. We call this scenario ambiguous engineering. Ambiguous because engineering is not explicit about which part to use. And finally, we have a part here, part F, which is not consumed. Well, at least not in this scenario. That means in this context where I'm using this model. So this doesn't lead to a misbuild, but it does represent the part which is not consumed. So imagine this BOM variant here is only consumed in the product by 2000, which we are using. If this part is never consumed, then we should probably consider leaving it out. Engineering, developing, handling all these redundant parts is very expensive. We want to avoid that, and it would be a great way to optimize our build materials. We call this scenario over-engineering because what we've done here, we've engineered a part that we really don't need. So we've done too much engineering. So what do we do if we find an error in one of these cases, over, under, or ambiguous engineering? Well, the system here should actually be able to assist us to give us an explanation and this explanation should determine the cause of the misalignment. So for instance, if I'm investigating this part here, F, this over-engineering scenario, I would like to be told something like this. We have a selection rule, looks something like this for part F. And the reason why you can't get part F is this combination of rules. Now I deliberately colored them different colors. So it could be that there are two rules from a technical module and one rule from a sales model that in combination make sure that we can never consume this part F. At this point, it's very important to stop and think, what does this mean? Because we call it BOM validation, but it doesn't mean that it's always the BOM which is, you can say, at fault here. Sometimes we actually do need to go and change the rules instead. So all we're doing right now is we've established that there is a misalignment between the bill of material and the configuration definitions. And by looking at this explanation, I should be given enough insight to figure out what do I need to do. Okay, so at this point, I've talked conceptually about how we would do such type of BOM validation and what kind of criteria we could validate. However, in practice, it's not really feasible to work with configurations using this explicit approach that I've proposed here. let's just look at complexity for a while. How complex can this be? The thing is that the number of configurations increase exponentially with the number of feature families that we have. So if you imagine we have feature families with just 10 features in them, that's not uncommon. That could be, for instance, 10 different mounting systems that would define how we mount the front derailleur to the bike. If we have feature families with 10 features in them, and we have just 8 of those families to drive the variance of a bill of material, that would yield 100 million different possible configurations. So obviously, with this insight, we can see that putting tables out like that in Excel or some other system is, for most practical purposes, not really feasible. So instead, let's start to think in solution spaces. So when I say solution space, what I mean here is I'm thinking in sets or collections of solutions or sets or collections of configurations. So I'm changing the picture a little bit. Now a square box that I'm presenting here, that represents all possible configurations over the features in my configurable module. So for instance, if I'm looking up here, you can see I have 3 feature families, one for cable, one for, I think it's bike type, and one for the mounting. And each of these feature families has 3 features in it. So that would yield a total of 3 times 3 times 3, 27 different configurations. And what I do is I select a solution space within that. So the blue bubble I have here, it represents all the configurations in here of all the possible configurations that are valid. And when I say valid, it's valid according to the rules of our configurable module. So in other words, this is what we offer to the customer. So the blue box here is everything that you can configure using the configurator. Now, I'll build another solution space that represents the bill of materials, the selection rules in the bill of materials in combination with our requirements. So again, the big square box here represents all possible feature combinations or all possible configurations. But the red bubble here, it represents all the configurations which yields a valid unit BOM. So that means that the selection conditions married with the requirements of what is a valid BOM. That together forms the red bubble here. By having 2 solution spaces, it's quite easy actually to determine if what we offer to the customer, the blue bubble here, is also buildable, the red bubble. And this is done by bringing these solution spaces together. So looking at this overlap, we can easily see if we have any kind of issues that we have to consider. So any error in this picture where the blue solution space, what we offer to the customers, is not covered by the red solution space, where the bill of material represents a valid product, that represents a configuration that would lead to a misbuild. So I've shown that here. It's a solution space with a little danger icon in it. And what we need to do now is we need to investigate the configurations in this solution space, and we need to fix the errors. How do we do that? Well, we already have the solution space. So we would go into this solution space and we would get what we call counter examples, some valid configurations in here that we know would lead to a misbuild. And for each of those, or at least a good portion of it, we would identify the type of error that configuration yield, over, under, ambiguous engineering, etc. There might be other selection or other criteria for what constitutes a valid BOM. Once we have that, we know the configuration, we know what goes wrong, we would obtain an explanation, as I showed before, and finally, we can determine where to fix it. Do we fix the rules? Do we fix the bill of materials? Where do we go? Perhaps we're trying to sell too much, so we fix the sales rules. Perhaps we haven't engineered enough, so we fix the engineering rules. Perhaps we have to strengthen or loosen or do something else with the bill of material. So let's try to summarize what we've talked about so far. So we've shown that to deliver on the configuration promise, we can make that possible. To do so, what we need is we need to have features and configuration rules and a configurable bill of material defined. We have that, and we have criteria that describes when a BOM is valid. It can be more elaborate than what I've talked about here. It could be about different parts don't go with other parts. But at least if we are validating something like BOM variance, it's quite clear. The criteria would be make sure every configuration yields exactly one part. If we have those two things, and we have the ability to work with solution spaces, so we can do this operation of projection, and we can do this operation of comparing solution spaces, such that it actually makes it possible to work with real world scenarios, real world sizes. If we have those three things, what we get is an ability to give a formal proof that the bill of material is validated against the rules, and that way we can actually prevent misbills before they happen. We also get a way to detect redundant parts. These are the over-engineering parts. And that way we make it possible to minimize cost and optimize the parts in the bill of materials. And finally, by having all this, we get insight how to fix misbills. We can help optimize the collaboration between engineering, marketing, and manufacturing simply by making really clear on a case-by-case what is wrong and what is all the data from all the different intents that goes into this scenario. And with that, I think we made it all the way just in time to have open for questions if there are any questions to ask.
Thank you, Anders. So I have actually got quite a few questions that have come in while you've been speaking. And of course, if you still got a question, would like to ask it, please do so in the chat panel, and I will take those as they come in. So I've got one here, Anders, that is the configurable BOM also included in Configit ACE?
Is the configurable BOM also included in Configit ACE? Today, we do not author bill of materials and the configurable bill of materials in Configit ACE. We do have the ability to execute what we call the explosion of the bill of material, and we have ability to analyze bill of materials, but we will usually get bill of materials from an external source. I talked a little bit about that in the tech talk that I referenced earlier, where I gave a few different options for where you would maintain your bill of material. I think at some point we might actually offer ability to author bill of materials, but what we've seen so far is that bill of material is a fairly well established it's a very established process at most companies, and most companies have their own well-established systems for doing that. So the answer is, what we see usually is that bill of materials are authored in a dedicated bill of materials systems, but you might want to bring it in to Configit ACE afterwards in order for example, to do BOM explosion for an order or do BOM validation, as we just talked about here.
Great, thank you. I've got another one here, and I hope I'm saying this one right. How do you prepare models or modules to have a good mating between them for final product configuration of 3D construction? That's a very specific question, so do try as you can.
Yes, that's a good question. Yeah, so my talk here talks very generally about bill of materials. It doesn't talk much about 3D construction. Obviously, when it comes to 3D construction, you're thinking, at least if you're working with a system like Configit Engineering, which is an integration of a configuration system into a CAD system, you would think very much in the CAD construction is really all the parts that goes into your CAD system. I think you would most likely want to break down your model if you can do that, so you can reuse your different components in your construction, your CAD construction, just the way that as you would break down your bill of material. But I think it depends on a lot of what system you have. So I think typically we see that when you have CAD construction, you have a fairly big monolith and a fairly big configurable model that you, for instance, use for parameterized CAD drawings. But I think going into more depth with this, people would break down their product models into much smaller parts, connect them to their CAD systems, and thereby getting much more reuse out of both CAD drawings and configurable modules.
Great. I've got a question here that's come through that says, does Configit support automated BOM validation? If so, how?
Yeah, so the thing I've been talking about here is a process where I think for most practical purposes, you would like to automate it. It's not something that you would do manually. That means when you change your bill of material or when you change your rules, you would like to run this process basically. Of course, you need your validation criteria about what constitutes a bill of material. But if you have that, you would like to run this as an automated process every time you change data, either being BOM changed or the configuration system being changed. So we do this for customers today, but it is not something that we have an out-of-the-box solution for, in the sense that bill of materials actually are quite different with different customers. So criteria change a bit, the structure of the bill of materials change quite a bit, but the foundation, the technology, and the way we do it is something that we have in today. And once that is established, it is definitely something that you want to do as an automated process, that you would run as a batch job. I'm not sure every night, but at least quite often, and definitely before we release data, definitely before BOM and configuration modules goes out for production.
Wonderful. So just keeping an eye on time, I think we only have time for one, maybe two more questions. And I've got one here that is how to optimize the engineer to order process to configure to order for order-based engineering.
Yes, so I haven't really touched about the difference between configure to order and engineer to order in this topic, because it's a very wide, I would say it's a very wide topic. And when you have engineer to order, you usually do not have the full luxury of just thinking of BOM validation as an automated process. So when we work engineer to order, we would probably require things to be a lot more flexible. What does that mean? Well, it means that you would probably be required to make configurations which goes outside the rule system that we have. You would probably also be required to do bill of material manipulations after an order is taken, because basically that's when you engineer things. I still believe that for even an engineer to order process, BOM validation would be a very useful tool, because you're not engineering everything. You're still reusing quite a lot of what you already have engineered, and you already usually at least have a very solid model that guides you in what constitutes a valid configuration. So with all that in place, I think you can reuse everything I've talked about here, even for a engineer to order process. But there will be areas where we step outside the boundaries, because, well, basically that's what engineer to order is. That is stepping outside the known boundaries of what we already defined. And thanks for listening in.